Yeah, welcome back to my channel. Today we will be covering Python functions. And so functions kind of like help us to make our code reusable and organized. And by being reusable, you avoid repetition. So for example, you have a block of code that you use in your program and it appears in different places. Instead of you just typing that block of code over and over again, and if there is any need to change anything, then you have to like go look for it over and over again. You just have that in the function and you give the function a reasonable name that once you call it once, then it performs that particular task. So that's just the idea behind Python functions. And so one, it helps you reuse your code, it makes your code more readable, and it helps you avoid repetitions of like the same code. I'll show you example just in a bit, but in this particular video I hope to show you, or what you tend to learn is how to create this function by defining them. I'll show you how to use the functions and how to actually optimize functions. And so this is how you create functions. You usually start with the def, which is for definition, or define, as in MATLAB they use define. And after defining, this is a keyword in Python actually, and then you give your function the name that you want to call anytime you want to execute that particular block of code. And here is an example. You define a grid, and in the grid, what this grid function is doing is just this code. It's printing a hello, and by the time you call this function with the grid, then it does that. So let's just see how that works here really quick. So you do a define, and this is a green because a keyword in Python, and then you could do a grid. And in a grid, after that you do a semicolon, a colon instead, and then you do whatever you want your function to do. In this case, we just want it to say hello, and that's all. And now we could call the function, and to call the function, just need to call the name of the function and parentheses. And if you do that, if we run this code now, it says hello, and we could even split this such that we run that and run this, and then it tells us hello. So whatever we say here, for example, hello Bernard, then if you run that, then it will say hello Bernard, you could say. And so that's how you define. Give it a name. It could be anything. It doesn't have to be grid, it could be anything. And then you pass in some code. And for functions, there is what is called arguments, and this is what actually you could think of them as input to your function. And this could appear as a positional argument, or it could also appear as keyword arguments, or you could even have some default argument, or you could even have multiple arguments. I will demonstrate each of these in the case, or you could even have a keyword argument where you could give dictionaries with using 2 asterisks. And so for the positioner, you just have one position. So for example, in this case, I gave no input here, but I could decide to give a name here and say greet someone by their name, and so it now needs a positional argument. So you have to, anytime you call this function, you can just call it this way. If I try running it now and running here, it will crash because it's expecting an input, but here I did not provide that input, and so the error has to do with positional argument name is not provided. So that's positional argument. And so to make it work, I need to provide an input, and this input could be a string. Notice I didn't even use it here, but complained because it's expecting that actually. And so instead of putting my name here, let's write it properly, and let's use the input, and let's pass in the name, which is the particular input that we'll give it here. We're using it here, so it says hello, and then says the name of whatever. And so here we'll pass in the Bernard here, and it needs to be a string because I'm using alphabet. And so if I run this now, it says hello, and it says Bernard. You could change this, or you could use it over and over again and change it to maybe Maria, and it brings hello Bernard and hello Maria. And so this is a positional argument, and so you could define your function to have some inputs, and usually these are called positional arguments. You have your name, which is the name of the function, and then you could give inputs, and then you have to use the inputs within your code. So the block of the code here, you use it there. In this case, I just printing. And so that was what I had in the slides. But also you could also define some defaults. So for example, instead of having my name, for example, if I know the name to be okay, it doesn't always change. It could change, but it doesn't always change. Most likely this is the name, then we could give it a default. And so we could say the name is equal to, for example, we could say we know that it's always our guest, and so that's the default. And so if I now call this particular function with nothing now, it wouldn't crash again compared to like before that it crashed. So if I run this code now and I provide a certain input to be binary, it will print binary. If I provide Maria, it will print binary. But if I don't give anything, then it will print a guess, because that's a default. And so that's what's happening. So by the time I provide a name, it overwrites the guess with the name I provide. But if I don't, instead of crashing as it was crashing before, now it uses that default as guess. Also, that's the second part where I talk about using default arguments. So you could define a function and give it default. So that way it doesn't crash, but there's a chance for errors, especially when you're doing for calculations and you have some default values here, and then the user doesn't know that it's supposed to provide an input and then runs with your default, and gets something, maybe it's expecting something different. Okay, and so it's good to make some notes and just be cautious about using default values. You could also return values from your function, and so let's write another function here, and let's do a little math now. Let's do math, and for this particular one, what we'll be doing is we'll define a function that squares a number, and so we just call that maybe square, and for the square it's going to receive some inputs, okay, and that would be a number, just call it num, and for it to square you just need to do num times num. If you remember, our square is just the multiplication of that same number. And so it did this particular calculation. You would choose to print the value. So if you just do a print of this particular value, it will work, it will just print, but you don't have access to that value. Like, so suppose you're using it to like do further calculations or further analysis with this certain value, since you're just printing it, it's only show to the terminal, but you don't really have it in your memory, and so you can use it. So for the return, it's when you want to use these values in the next step, or you want to have access to this particular operation that you did with this function, then you have to return it. That way it's saved in the memory. And so if I run this function now, if I call it now, remember to call the function, it's just the name of the function, so that's square, and then you provide an input. Remember, it's expecting an input. If I don't provide anything because I did not define any default, it will crash. It will complain about positional argument, which is that. But if I provide in 5, I want to square 5, it should be 25, and if I run it, I get my 25. So it just printed that. But if I do a whos, now I only get them as functions, so there's no variable of type integer. So there's no type integer for this particular one because it's not in memory. Okay. But if we want to have access to this value 25, then we have to, instead of printing, we could just do something like, we could choose to print if we want, but you don't really need to print. You could just, let me just copy this, and you could just say something like return, and you could just tell it to return, that's giving back, and then you could pass in whatever you want to return. You don't even need those, and you could even comment this because we don't really need that, except we want to see the value. Now if I run this particular one, if I use a return, then I have to receive this in a variable, and so I can just run it that way. So if I run it this way, I do not run that. If I run it this way, it's there, but like if I do a whos, then I wouldn't see have that value. So it's basically just printing a value still. But if I want to receive this particular value in variables, then I could call that variable x is equal to this, and I could use to print x. And so I will do print my x. Okay, what if I don't do x? Nothing will show up, so I want to see 25. But it's stored in x now. If I do whos, I have my x, and x has the value 25 now, and it's an integer. But if I do a print x, then I have that 25 shown here, and if I do that, I have that in memory too. And so that's how you basically define and use function. In this case, I'm just showing you how to use a return. And so with return, you have the ability to receive it into a certain variable that you could use for your calculations. What if you just want to use that particular function once? Then you could use what it's called a one-line function with the lambda. And so you don't have to start thinking of what name will I have to give to this particular function. Since you're using it just once, you could use a lambda function. And for lambda function, one example would be this square. Instead of like defining a square, which after maybe one time you don't need to use it again, since square is a different, like you could predict the relationship, then you could just use a lambda function. And so with lambda, you just do something like this. And so we could do something like the square sqr is equal to, we just do a lambda, and we provide in the key is x, for example, and then we provide you provide the key and the value will be x times x. So this is the formula, and this is the variable. And so if we run this now, we have a function called the square. If we, or since squared, let me just call it squared, since I already have squared in memory so I don't confuse you. Okay, squared. And if I run this again, and now if I call this particular function squared, let's print the value from that particular. If we print the value from this particular function squared, and let's give it a 3 now, what will happen? To give us a 9, because it's just picking the x, which is at 3, and doing 3 times 3. So you could also have like one line on anonymous function. This way you don't have to worry about brainstorming or giving it a name or using the standard way, and it's pretty fast. And so these are more practical examples, just to help you at this point. Like if you've understood what I've explained so far, you're pretty good to go with function. Like you already know everything about function basically. But if you want to be more efficient, then you could stick more to this video and understand what I'm explaining next. And so here's one example. We are defining the function. This is a practical example. You could write a function that converts units. So you can convert degree in Fahrenheit to Celsius, or Celsius to Fahrenheit. You convert kilometers to miles, or miles to kilometers, whatever. So those are practical examples, and that will be happening over and over in your code, right? And so in this case, you just convert. I'm not going to type it here, just explain here. You define your whatever task you want to perform, which is the name of the function, and it's expecting an input. Since you're converting Celsius to Fahrenheit, you should have the value of your Celsius, and so that will be the input. And what you want to return is the value of your Fahrenheit, and then you type in the function of your Fahrenheit, which is just your Celsius times 1.5 plus a 32, and this will give you a degree in Fahrenheit. And then if you print that value, then that should give you the correct thing. Or you want to write another function there, would just check whether a number is even or odd. Then you have to just rely on it being divisible by 2. So anything that would use the module or mod of 2, it should be 0. So there's no remainder after you divide any number by 2. If there's no remainder, then that's an even number, and then you should print even number. And so those are practical examples, and that's just the syntax of like defining and calling functions. And so here are the best practices when it comes to function. You should give a name that is meaningful. And so remember, when I was doing a square, I gave it a square. You should try to always come up with a name that is meaningful. This way, when you like go back to your code, then you don't have to like, or when you want to like fetch a piece of code to like use, which is a function, then you don't have to like overkill yourself to try to understand what that particular code is actually doing. By giving it a reasonable name in square, if I just see this, I know that it's a square, it's actually squaring. So it's good to give a meaningful name, but also should keep your code very short and focused. So don't do a bunch of unnecessary stuff in the function. If it's just square, just do only the square and get out of it. Don't start doing additions and some multiplications within it. Use comments. In this case, I was not using comment, but try to use comment. And to use comment, remember, I was already explaining in all of our videos, you just need to do a pound and type whatever. So we could just say something like this function squares 2 numbers, and so those are the 2 numbers you provide to it, and then you should keep that. And then remember to test the function. That's what we've been doing here. We'll always test the function with different numbers. What if I give it a 5.2? So initially I was given an integer, now I'm giving the float. Will it still work? It will work to give me this out. What if I give an alphabet? It wouldn't work because it's actually a multiplication, so that would crash. So make sure you test it across different numbers with different inputs and see how your function behaves. And use defaults where appropriate, and so when necessary, use. If it's a square, there's no need of giving a default value of 3 because you don't know what the user wants to do a square of. But if it's something that you could predict, then it's good to give some default value. For example, if it's a module that you know the default values that works best, then you could set those values as a default. For example, if it's a smoothing operation, that maybe it's a Gaussian smoothing operation, that you know that the user is most likely going to use image of this resolution, and this is the window size that work best for Gaussian smoothing, then you could use those as the default window size, you know. And so those are kind of like the judgment you perform in your head before setting those default values. And so yeah, this is just a summary of what we've covered so far. We're able to introduce a function saying that instead of repeating your block of code over and over again, that will tend to like stress you and then want to make any slight changes to the code, then you could just use function to like avoid repetitions within your code, but also make your code more readable and efficient to run. And I also explained how to use inputs to argument, which are inputs to functions, which we are calling arguments, and how you could be flexible with like using by using some default when necessary. I showed you how to receive values back from your function since the scope is different, and operations or variables that you define within your function want to stay within your function. Then if you need them out, you have to use the return to receive what you want out. And then I also demonstrated how to use Lambda function, which are pretty fast and autonomous function. And with that, please practice with a bunch of other code and let me know how it goes. So this is actually designed for beginners. There are a bunch of other stuff that I would have loved to bring into this particular video, but I want to keep it as easy as possible. Let me know if you need the part 2 of function writing, but with this you're pretty good to write functions in Python. See you in my next video. Bye.